Hi guys, I'm back, and today we're going to be going over multiplication and division of decimals. So this is the same standard that we went over yesterday, but I basically just broke it up into two parts because I think learning all four would be kind of a lot in one chunk, and I think that we probably would need a little bit more practice with multiplication and division of decimals than we would with addition and subtraction of decimals. I'm sorry for all my sniffles yesterday, but just to let you guys know, it has turned into a full cold. So I probably won't sniffle as much, but I might sneeze, so we'll see how this goes. And I might sound a little funky, I don't know. So yesterday we were talking about addition and subtraction of decimals. The number one thing that I was focusing on was that you needed to line up your place values or line up your decimals. The same is not true when we are multiplying decimals. So when I'm multiplying decimals, say I have one number that has one of my numbers has one number after the decimal, and then the other number has two numbers after the decimal. That is fine. They do not have to line up with place values, and you do not have to add zeros. I often see people lining up or adding zeros in because they're so accustomed to lining up decimals or lining up place values and then adding in zeros. That tends to lead to more mistakes. You'll still get the same answer, but then you just have all these rows of zeros that just kind of throw you off a little bit. So I would suggest not doing that. I would suggest lining it up to the right instead. So what I mean by that, I'm just going to come up with two numbers. This is kind of hard to write on. Let's say like 18.4 times, let's do 0.37. My decimals. That might not be big enough. Let's, come on closer, little buddy. Is that easier to read? You can't really see the practice thing. Let's try this. Good. Okay, so we have 18 and 4/10 times 3,700. Sorry, I said that wrong. My bad. But you guys know 18 and 4/10 and 3,700. So when I'm writing that, I always put the number that looks longer, and I don't mean bigger. I mean longer up top. So that would be the 18 and 4/10. That has three numbers. This has two numbers in it. So I just literally mean like what looks longer. And then I will put 0.37 on the bottom. I did not have to line up my decimals here. One of my decimals is here, and one of my decimals is there. They are not lined up with each other. My place values are not lined up with each other, but that's okay because when I'm multiplying decimals, I do not worry about my decimal until the very end. If you know how to multiply two-digit numbers by two-digit numbers or three-digit numbers by two-digit numbers, or really if you just know how to multiply in general, you can multiply with decimals as well. It's the exact same thing. The decimals should not throw you off because you're not worrying about them until the very last step. So right now I'm just going to multiply this like I would normally multiply a problem. So I'm going to start with my bottom right number. So I'm going to start with my 7, essentially, is what I mean there. So I'm going to do 7 times 4, which is 28. I'm going to do 7 times 8, which is 56, plus 2, which is 58. And I'm going to do 7 times 1, which is 7, plus 5, which is 12. Now, when I'm essentially done with this number. And if you want to cross that number off, you can. If it throws you off because you're like, I don't remember which numbers I've been multiplying, especially when you get into bigger numbers, absolutely you can do that. I'm not going to do that for right now just because I don't want it to get too busy. But now I'm going to move on to my 3. But since I'm multiplying by a different place value, I do have to add a 0 right here. Okay, because now I'm multiplying by the tenths. I'm not multiplying by my hundredths anymore. Basically, just remember that every time you add a line, you add an extra 0. So one line, the first line down would be 1 0, 2 would be 2 zeros, etc., etc. I guess technically it would be the second line down, but you know what I mean, when you add a new line. Okay, so now I have 3 times 4, which is 12. I like to erase those because I think that they get confusing if you don't erase them. That's why I prefer to do things on whiteboards, but if you have a pencil and paper, maybe just erasing it. That's why I really don't like working out math in pen. 3 times 4, 3 times 8, which is 24, plus 1 is 25. 3 times 1 is 3, plus 2 is 5. I'm not doing the best writing of all time here. Now I'm just going to add them up. So I have 8 plus 0 is 8, 2 plus 8 is 10, 5 plus 2 plus 1 is 8, and those are not lined up at all, but it should be 5 plus 1, which is 6. Okay, so now I actually have to worry about my decimal. Okay, so all I'm doing is I'm looking up here and how many numbers do I have to the right of a decimal. My first number, 18 and 4/10, I have 1 because I have that 4/10, right? And then in my second number, I have 2 numbers to the right of a decimal, which would be 3 and 7. So I have 3 numbers after the decimal in my problem, which means I have to have 3 numbers after the decimal in my answer. So my answer should be 6 and 808 thousandths. Check to see if you did that one right. If you paused it. I didn't tell you to pause it. Again, I forgot to do that again. But even if I don't tell you, if I write out a problem, pause it, solve it, see what you get. Okay, I got a new whiteboard. Oh, I mean, I didn't get a new whiteboard. I brought a new whiteboard from home. That doesn't make sense. I brought a new whiteboard from school home. And I hope we can appreciate how much better that erased. I have nothing on there. Look at that. That looks good. It's a lot smaller, though, so I hope it's still easy to read. All right, we're going to do another problem. This time, hopefully I'm going to remember, but pause it and work it out before I do. So first I'm going to set it up vertically so you guys have practice setting it up. That's not right. Did I say that wrong that whole time last time? I'm going to set it up horizontally so that you set it up vertically. Jeez, I hope I didn't mess that thing up that whole last video. My bad if I did. All right, so I'm going to write 8 3/10 times 4 7/10. Set that up vertically. Pause it. Do it. Hi, welcome back. I hope I set it up. If you want to pause it again and work it out, go for it. Go. Hi, welcome back again. Okay, so we have 8 3/10 times 4 7/10. So I'm going to set that up vertically. 8 3/10 times 4 7/10. Right? Is that what you did? If you did not do that and you did it a certain way and you need to fix your mistake, you can pause it right now and you can fix it and you can solve it. But either way, pause it, solve it. All right, welcome back. I am going to erase this just for my own sake, just because I feel like it's going to make it easier. And I'm going to start with my bottom right number, which is my 7. So I'm going to do 7 times 3, which is 21. 7 times 8, again, 56, plus 2, 58. Next line, I'm going to add my 0. 4 times 3 is 12. 4 times 8 is 32, plus 1 is 33. I'm struggling to write like this. Jeez, that looks bad. Sorry, that was my alarm. And now I'm going to add them up. So 1 plus 0 is 1. 8 plus 2 is 10. 5 plus 3 is 8. Plus 1 is 9. And 3 plus nothing is 3. But I'm not done yet, because if I'm like making sense of this problem, that's like kind of like 8 times 4 or 8 times 5, right? So I know that my answer should be about like in between 32 to 40, right? Because that's a little bit more than 4. This 3,901, that's not right. That doesn't even make sense, right? Because I still haven't added my decimal. So I have to look up here and see how many numbers are to the right of a decimal. I have 2. I have 1 in my first number and the other in my second number. So there needs to be 2 numbers to the right of my decimal in my answer as well. So my answer should be 39 1/100th. So if you get an answer, make sure that it makes sense. That's what that whole estimation thing is. That's why in grades like K through 5, they really, really emphasize estimation. In 6th grade, we're really starting to focus on the standard algorithm, but we want you to be able to estimate your answer first, just to make sure that that even makes sense. Because if you were to have gotten, I don't know, that sounds funny, 3,901, you should be able to look at that and be like, wait, that's about 8, that's about 5, right? That should be about 40. That doesn't make sense if my answer is 3,000. That's like a whole different number. So then you can go back and see like what step am I missing. Okay, I'm going to do one more multiplication problem before we move on to division problems. And I'm going to do a whole number times the decimal just for fun, okay? So let's say my whole number is 15 and my decimal is let's do 400ths. So 400ths. Okay. If I were to set this up, again, I want to focus on the fact that I do not have to line up any decimals when I'm multiplying. I'm just stacking these. Wow, that looks bad. And I'm starting with my bottom right number, which is 4. So I'm doing 4 times 5, which is 20. Oh, I didn't give you a chance to pause. I gave you a pause and work out the rest of your own. Okay. Now we have 4 times 1. So you should have gotten 20 for your first step. We already did that. 4 times 1 is 4 plus 2, 6. Next line, I'm going to add that 0. 0 times 5, 0. 0 times 1 is 0. Now if I'm adding these up, 0, 6, 0. Okay. I have to make sure that I add my decimal in this problem. And a big mistake that I see is people somehow getting the wrong answer for how many numbers are after the decimal. There is no decimal in a whole number, right? There is no decimal. There is nothing I have to worry about there. The only number that are after the decimal or after a decimal are 0 and 4. That 400ths are numbers after the decimal. There is no decimal up here, so I don't count those numbers. There are only 2 numbers after the decimal in this problem, which means there needs to be 2 numbers after the decimal in my answer. So my answer is 0 and 60 hundredths, or which is also the same thing as 0 and 6 tenths, which is also the same thing as just 6 tenths, right? So if you got any variation of these answers, that is right. They're all the same thing. 60 hundredths and 6 tenths, same thing. Okay, if you want to do some more practice before I move on to division, same thing as yesterday, that same website. If you go to mathaids.com, you should be able to find a sheet that just has a ton of different sample problems for multiplication by decimals, and you can even choose like how many numbers you want after the decimal. So you can kind of start easy and go harder. If you already feel like you are pretty good at it, you can just start hard and just see and make sure that you're getting your answers right, because remember, that's a major key. You got to make sure that you're not practicing in the wrong way. So check your answers after you finish. Don't just assume that they're right, okay? Now we're going to go on to division. Okay, for my first division problem, I wanted to start off relatively simple in that we probably either know our sixes or we have a way to check our sixes. A little bit easier than, say, if we started off with like 29 or 157 or something like that. So I'm trying to start this off just so that we kind of remember the basics of dividing with decimals rather than going straight into like the hardest possible problems. What's important when you see a problem written horizontally like this is that my first number that they write, that is my dividend. So that's the number that goes inside the box. So this is 3 and 78 hundredths inside the box. And this guy right here is my divisor. So 6 is my divisor. Miss Perry helped me remember that by Divisor Supervisor. This is the guy watching everybody in there going like, what are you doing, right? This is like the yard duty or the teacher. That's me. I'm right there. So make sure that you're setting that up correctly. You would read that as 3 and 78 hundredths divided by 6. That is not the same thing as 6 divided by 3 and 78 hundredths. Order matters with division. Order does not matter with addition. Order does not matter with multiplication, but order very much so matters when we are subtracting or we are dividing. So make sure that you set that up correctly. Your first number goes inside the box. Your second number goes outside the box. Divisor, dividend. Hello, Chomper. Chomper wants to learn math too. But you might be very good at math. I haven't taught you yet. Okay. So I'm going to start by looking at this and saying, can my divisor go into this first number? So can 6 go into 3? No, that's too big. That's not right. Okay. So now I'm going to look over and I'm going to say, now can 6 go into 37? Yes, it can absolutely go into 37. It can go in there 6 times, right? So I have to write that number above that 7. But here's the thing that I missed. I have to bring that decimal up. That's going to give me a very different answer if I did not bring that decimal up, because that's 6 versus 6 tenths. Those are very, very different numbers, right? That's $6 versus 60 cents. Not the same at all. So I have to make sure that I put my decimal up. That could even be your very first step. And I want to make sure that I'm putting that 6 above the second or the last number that I looked at. So I was looking at 37. This would be where I would have to go up from. So 6 times 6 is 36. 7 minus 6 is 1. 3 minus 3 is nothing, so I'm not even going to worry about that. And then I'm going to bring down my next number. Remember in my class, we remembered this as DMs. And then, yeah? So you're dividing by your first number, then you're multiplying, which is where we got that 36, and then you're subtracting. I'm sorry, that's annoying. Okay, so now we have 6 can go into 18, so we're doing that dividing part. 6 can go into 18 3 times, or 18 divided by 6, same thing. Now we're going to multiply, so 6 times 3 is 18, and now we're going to subtract. 18 minus 18 is 0, so I am done. That sliding down is really just my bringing down the next number. We don't have any next numbers, so that's why we're finished. So your answer should have been 63 hundredths. Check to make sure you got that right. Okay, so for my next problem, I'm going to increase the difficulty level a little bit. And I see a lot of different ways that people, like students, will solve these kinds of problems. The way that I encourage is probably different than what some of you like to do, to be completely honest with you. I know most kids like to do the guess and check method, and what I mean by that is, okay, I don't know my 15s, so I'm just going to like write it all over here and like write it like this and then like that, and then just kind of see what works. But that gets really messy, and you end up doing the same amount of work as you would if you were to just make a chart in the first place. So what we're going to do in here is we're going to, on here, we're not in anywhere, is make a chart of our 15s, because I think that makes it smoother. It's easier to like find your mistake, and it's more organized on your paper. So I just think that it works better. If you like the guess and check method, go for it. Do you, man. Live your best life. That's fine. As long as you're getting the right answer and you're checking your work. That's the major key. So whatever situation or whatever solution or whatever strategy works for you, do that. But what I'm going to do is I'm going to make a chart of my 15s because I think that it works the best. Geez, the sun is just going in and out. So I'm probably going really light, really dark, really light, really dark. Okay, so I'm going to make a chart of my 15s. I'm going to make them down here. No, that's not easy to write with. I'll do them right here. 3, 4, 5, 6, 7, 8, 9. Yeah, you can kind of read that. This is especially helpful when you get into like really big numbers. So like you're dividing by like 3-digit numbers or 4-digit numbers, or even when you're just getting up there and like numbers that is like, I couldn't even guess. I mean, you can always guess because you can always estimate, but you know what I mean. Okay, so I'm going to count by my 15s. Usually I would have one member of the class do each number, or 2 members of the class do each number, but I'm by myself and I have nobody to help me out, so I'm just going to make it. If you want to pause and write your 15s chart, do it now. All right, welcome back. Now we're going to do our 15s, and I'm going to pretend like I have you guys answering my questions and telling me what you guys got for your answer, but I don't. Okay, so 1 times 15 is 15, 30, 45, 60, 75, 90, 105, 120, and 135. That might be really hard to read, so I apologize. That's why you wrote it down in your paper too. Reference sheet. Okay, so now I'm going to look at this. Can 15 go into my first number, which is 6? Can 15 go into 6? No. Another thing that I see people do, which I think is an awesome strategy, is, okay, it can't go in there, just write an X there, or write something, write a smiley face, write a heart, I don't care. Just write something there to like remind you that you cannot put your next number on top there, because that will change your value, especially when we have decimals, okay? Okay, so 15 cannot go into 6, but can 15 go into 67? I'm going to look at my chart, and I'm going to say, yeah, it can certainly go into 67, and it can go in there 4 times, because if I hit 5, that's too big, right? But 4 is just under. So 15 times 4 is 60. I'm using my chart here. 7 minus 0 is 7. 6 minus 6 is nothing, so I'm not even going to worry about that, and I'm going to bring down my next number, which is a 6. Can 15 go into 76? And I'm going to look at my chart, and I'm going to say, yeah, it can go into 76. It can go in there 5 times. So I'm going to write my 5 up here. 15 times 5, I'm looking at my chart, is 75. This is getting a little wonky, but we got it. It's sliding. It's all right. 6 minus 5 is 1. 7 minus 7 is nothing. But before I'm going to bring down that next number, before I'm going to bring down that 5, I've got to take care of this guy right here. I got to remember he's got to have a place. So I'm going to bring him up so he goes in his little decimal spot, okay? And now I can bring my very wonky 5. And I know this, 15 can go into 15. Any number can go into itself 1 time. So 15 times 1 is 15. 15 minus 15 is 0. I have no numbers to bring down, and I don't have a remainder, so I am finished. So your answer, if you paused it and went first, it should have been 45 and 1/10. Check to make sure that that's what you got. Okay, so for my next problem, I'm doing what I would like to call a challenge problem, but honestly, it's not a challenge problem. This is a 6th grade standard. So you should be able to have multi-digit dividends and divisors. So right now obviously we have multiple digits in here. We have in our dividend, and then we also have a multi-digit divisor. But we have a decimal in our divisor, and when we are dividing, we do not want to have decimals in our divisors. Our decimals in our dividends, fine, that's okay. But decimals in our divisors, we typically like to get rid of those because it makes it a lot easier. So in order to get rid of this, I'm basically going to be able to be creating an equivalent ratio or multiplying it by 10. And that sounds a lot harder than it is. Really all that means is if I multiply 3.1 times 10, I'm just moving my decimal over to the right once. But if I do that in there, I have to also, out here, I also have to do that in here. So my decimal has to move to the right once out here too. So my new number should be, oh, that looks bad. That looks really bad. 12,985 and 9/10 divided by 31. So my goal there was to just get rid of the decimal in my divisor. So now I have a number divided by 31. Do I expect any of my students to know their 31s? No, that's not on our multiplication chart. So when we get to these harder numbers or these larger numbers out here that we do not know off the top of our heads, that's when we make our own chart, okay? I want you to pause right here, and I want you to make your own chart of your 31s. I'm going to pause, and I'm going to do the same. And when we come back, we are all going to have a chart of our 31s, and it's going to be glorious. Okay, be right back. Okay, I erased that whole section. I just need the board, to be honest with you, and I'll write it down in like the description box so that you guys have a way to find those sheets, but it's just taking up too much board space right now. So I have my chart of my 31s. I hope that you have your chart of 31s too. You better. I paused you. I did it. You got to do it too, all right? So I'm going to look at my number, and I'm going to see what can 31 go into. So can 31 go into 1? No. That's obviously 1 is way too small. That doesn't fit. You can put your X. You can ignore it. Whichever one it works. Can 31 go into 12? Nope. That's still way too small. If you want to put another X, that works too. But now I'm going to go over to 129. Can 31 go into 129? And I'm going to look at my chart, and I'm going to say yes. It can go in there 4 times. And that is 124. So I'm going to write that down here. 9 minus 4 is 5, 2 minus 2 is nothing, and 1 minus 1 is nothing, so I'm just going to ignore that. And I'm going to bring down my next number, which is an 8. Can 31 go into 58? Well, I know 58 is bigger, so I know that it can go inside there. Let's just see how many times. 1 time, because 2 is too many, that's 62. So I'm going to write my 1 up here. 31 times 1 is 31. 8 minus 1 is 7. 5 minus 3 is 2. And now I'm going to bring down my next number, which is a 5. So now I have 275. And how many times can 31 go into 275? I'm going to look at my chart and be like, oh, well, that's too big, right? 279 is too big. So I'm going to go up here to the 8, which is 248. And here's my subtraction skills coming in, right? 5 minus 8, I can't do that. I can't. I've got to borrow from somebody else. So I'm going to borrow from the 7. The 7 becomes a 6. Now that has 15. 15 minus 8 is 7. 6 minus 4 is 2. 2 minus 2 is nothing, so I'm going to leave that alone. I know I have to bring down another number, but before I bring down another number, I have to look at this guy right here. I'm not going to bring down my decimal. I got to bring that guy up. He's the only guy that just floats to the top. He's not going down with me. He is going up, all right? And now I'm going to bring down the 9. Not a very pretty 9. My bad. So how many times can 31 go into 279? 9 times. 31 times 9 is 279. 279 minus 279 is 0. I have no other numbers, and I ended up with a 0, which means I am finished. So my answer should be 418 and 9/10. Make sure that that is what you got, and if not, take a second. See what went wrong. A big thing that I see that goes wrong is this part right here. We see 5 minus 8, and we say 3. That's not right. That's not right, and that'll throw off your whole answer. So make sure that you're using the skills that we've learned with subtraction, with like multiplication, with all of that in order to ensure that we get the right answer, because division really is one of those operations that requires you to be proficient in everything else. That's why it's the last one that we learn, because it requires you to be proficient in addition, subtraction, multiplication, and also division. So check your answer. Again, if you want to do extra practice on these, mathaids.com, to the left-hand side, decimals. Make sure that you're exiting out of that thing that says pick a grade, because that'll get you. And they might ask you multiple times. Today when I went on it, it was asking me multiple times. But just exit out of it, go to decimals, and then there should be practice sheets for division. Make sure you check your answers. Okay, guys? All right, I hope this is helpful. Let me know if it wasn't. Let me know if there's something that you need more help on, if there's any extra problems that you want assistance with, or anything. The next thing that I'm going to go over is probably either division, probably division of fractions, because that's that same standard, which is number system, sorry, not number sense. So probably either fractions, or we might get into ratios pretty soon here. We'll see. Bye, guys.